Hi everyone! Today we're solving problem 23. In this problem we're told that a number n is abundant if the sum of its proper divisors exceeds the number itself, and that all integers greater than 28,123 can be written as the sum of two abundant numbers. We need to find the sum of all positive integers which cannot be written as the sum of two abundant numbers. Let's start by calculating the sum of the proper divisors of a number. So I'm going to create a method, proper divisors sum, which takes a num of type long. You might remember that in problem 21, I calculated the sum of the proper divisors of a number by first calculating the proper divisors and then summing them up. And I realized soon after solving that problem that there's actually a faster way to calculate the sum of the proper divisors using the prime factorization of the number. So I've put the prime factors function in the util object, and we're going to use that here. So first let's start by calculating the factors of num, and that's going to be util.prime factors of num, and that gives us a list of long. Now, in this formula for calculating the sum of the proper divisors, what we do is we group all of the prime factors by themselves so that we get the prime factorization in terms of prime numbers raised to different powers. So for example, for 120, we would get 2 raised to the 3 times 5 times 3. So to do that, we do factors.groupBy. So groupBy is a method that groups all of the elements in a collection based on a grouping function. So in this case, we want to group by themselves, so we use the function identity, which is a function provided in Scala that takes an element and gives that back. So let's check that this works. We'll do proper divisor sum of 120. So we can run this. And we get a map of 2 to list 2, 2, 2, and that represents 2 raised to the 3. Then we have 5 raised to the 1 and 3 raised to the 1. In this formula, what we do is we take each power and we calculate the sum of all powers from that base all the way up to the highest power found in the prime factorization. So for example, in 2 here, we would sum up 2 raised to the 0 plus 2 raised to the 1 plus 2 raised to 2 plus 2 raised to 3. And for 5, we would do 5 raised to the 0 plus 5 raised to the 1, and similar for 3. So to do that, we're going to map, and here we can use pattern matching to extract the values out of the tuples we have. So it's going to be base and group. I'm going to start by calculating the power from this base by doing group val count is group dot length, and to calculate the sum 2 raised to the 0 plus 2 raised to 1 and so on, we can use the sum of a geometric series. So the formula for that is 1 minus the base raised to the highest power plus 1. So for that, we can use math.powell, and we can do the base is base, and the power is going to be count plus 1, because that's how the formula wants us to do it. And we can safely do a 2int on this because of the definition of math.powell. In the definition of math.powell, it says, if both arguments are integers, then the result is exactly equal to the mathematical result of raising the first argument to the power of the second argument. So we can safely do a 2int here. And in the formula, what we do is we divide this by 1 minus the base. So now we can run this again, and now it should print the individual sums. And we can see that this is correct because 15 is 2 raised to the 0 plus 2 raised to 1 plus 2 raised to 2 and 2 raised to 3. And the same goes for all the other values. 6 is 5 raised to 0 plus 5 raised to the 1. 4 is 3 raised to 0 plus 3 raised to 1. And the last step of calculating the proper divisor sum is doing dot product. And what we have to do one last thing here, because this formula gives the sum of all divisors including the number itself. But we don't want to include that since this is the proper divisors. So you do minus num. Now we can run this to get the proper divisor sum of 120, and you get 240. Now let's implement the check of if a number is abundant. So we can do is abundant num of type long. And all we have to do is a number is abundant if the sum of its proper divisors exceeds the number. So this is proper divisor sum of num is greater than num. So now we can have a check if a number is abundant. Now to calculate all the numbers, which cannot be written as the sum of two abundant numbers, I'm going to start by calculating all of the abundant numbers under the limit they gave, 28123. So I'm going to do val abundant numbers is equal to 1, 2, 2, 8, 1, 2, 3. Let me check that I got that. Yep, 28123. Dot filter is abundant. So this gives us all of the numbers that are abundant. We have to do one thing here. We have to make sure this is a long range, because is abundant takes a long. So now that we have the list of all abundant numbers, what we're going to do is we're going to mark all of the numbers. We're going to generate all of the possible sums that two abundant numbers could produce and mark them in a marker array. So I'm going to create our marker array. Val abundant markers. And in Scala, to create an array, we just do new array, provide the type. So this is going to be a Boolean array. And we can provide the size. And we know that it's going to be 28123 because that's how far we need to check. Now to calculate the possible sums of pairs of abundant numbers, we can do a for comprehension. So you can do for, and here we can do a small optimization that we only want to count a pair of abundant numbers. We only need to check it if the index of the first abundant number is less than the index of the second. Because it doesn't matter if the abundant numbers are switched because we're multiplying them. I mean, not multiplying them, adding them. So what I'm going to do is I'm going to have the first index, we can call this A, is going to be in abundant numbers dot indices. Now indices gives us a range of all of the indices inside this collection. So this would be 0 to the length minus 1. And B, the index of the second abundant number we're checking, we don't need a semicolon there, is going to be A, because we want to include A, because we might be adding an abundant number to itself, until abundant numbers dot length, so till the end. And then for each of these pairs, we have to first check that the sum of the abundant numbers has to be less than or equal to 28123, because you know any number past that is going to be going to be representable as the sum of two abundant numbers. So I'm going to do abundant numbers at A plus abundant numbers B is less than or equal to 28123, and we can get rid of those parentheses. Now once we get these two indices, we can set the marker, because we know that the sum of these two can be represented as the sum of two abundant numbers. So abundant markers at, and we're going to do abundant numbers at A plus abundant numbers at B, and we need to subtract 1 because our array has 0-based indexing. I actually need to expected int actual long. Oh yeah, because our abundant numbers contains a bunch of longs, so we can convert these to ints. So now we're able to fill up our marker array. Now all that's left is going from 1, 1 to 2, 8, 1, 2, 3, and we want to filter the ones that aren't marked in our marker array. So we're going to use the method filter not, which is the opposite of filter. And this is going to be n, which gives us the number we want to check, abundant markers at n minus 1. And the reason here we're doing n minus 1 is, again, we have 0-based indexing. And you need to sum these up, and that's what we're going to print. So let me put that in there. And we can run this. Interesting. We're getting a division by 0. Let's see what's that we're getting here. Aha! So what we're doing here is we're going through the prime factors and we're looking at all the bases. We're getting division by 0 when our base is 1. And that's happening because when we get the prime factors of 1, we're returning just 1 in util, because if we don't find any prime factors, we just return the number itself. So we can fix this by starting from 2 in our abundant numbers, because we know anyway 1 is not going to be an abundant number. And this is interesting. I think I know what went wrong here. So we're looking at abundant markers, but we're not setting it to anything. So you need to do equals to true. And that should work. Let's try running it. And it works. We have our answer, 4179871. So that's it for problem 23. I'll see you next time when we solve problem 24.